All right, round 4 apparently, because I keep making mistakes. Johnny has decided to go skydiving. He steps out of a plane and now flying an altitude of 26,400 feet. With initial upward velocity of 0 seconds, he will not try to slow down his descent by spreading his arms out against the wind and creating drag. Part 1 is just a model, so you're rewriting this thing. This is going to be height as a function of time is negative 16 t squared plus the initial velocity. The initial velocity is given in the text as 0 plus 0 t, and then plus h subscript 0, which is initial height, which is 26,400. For some reason, I've had to do this problem again because I keep changing it to 25,400. I don't know what's wrong with me today. It's just one of those days. Now, when your final answer, you don't need to mention anything that's a 0. There you go. Height as a function of time is negative 16t squared plus 26,400. Now, I'm going to show you how to check your work in a calculator on this one. If his parachute opens up at 1,000 feet, how long has Johnny been in free fall? So we're simply going to replace that height with 1,000. And what we're going to do is we're just going to do some shifting. 1,000 minus 26,400 is negative 25,400. And that equals negative 16t squared. Divide out the negative 16. And I will need my calculator for that because I am too tired to do that. All right, make this a little bigger. We're taking a negative 25,400. We're dividing her by the negative 16. It's going to be positive, obviously. And we'll get 157.85 being equal to t squared. 1,587.5 being equal to t squared. Told you I was wore out. Now, the opposite of squaring is square rooting. And usually we talk about plus or minus, but we are in the real world here. Is there any such thing as negative time? I don't believe there is. And you get 39.84 seconds. There is also the negative answer to this, but that would be extraneous. Now, let's check this against the TI-84. We're going to go to y equals. Maybe you remember doing this, maybe you don't. We're going to put the 1,000 in y1. And we're going to put the equation into y2, negative 16 x squared, because we don't have a t, at least not until you guys learn about parametric equations, plus 26,400. I always tell kids to do a Zoom 6 because you've probably used the calculator on a previous problem or somebody else has. But a Zoom 6 on this problem is worthless because Johnny is 26,400 feet in the air and this only goes up to 10. So go to Window, go down to Ymax, and you need to be playing along, kids, or this will never click. I'm going to set my Ymax to be 30,000 foot. And I'm going to hit graph, and I should start seeing things happen this time. Now, the reason I haven't seen the two graphs intersect is because that happens in the future. This is 10 seconds. We already know it's supposed to be around 40 seconds, right? So go back to Window. Let's set the X max to be 50 because there's another part to this question. 50 ought to do the job. And hit graph. And you should see an intersection happen. And you should be playing along. Go to ti84calc.com if you don't have one. Or don't. Second trace 5. All you gotta do is have your cursor in the same neighborhood as the intersection, and then you press enter 3 times. And there you go, 39.84 seconds, which is what I had by hand, kinda. All right, the second one, I'm gonna let Johnny live, so his parachute's gonna open up at 20 foot, okay? Or sorry, his parachute does not open, but he smashes into an inflatable that is 20 foot tall. You are more than welcome to use the ground, which is 0 feet tall. But I'm going to be nice today. I don't want to be nice, but this is on YouTube. I actually want him to smash into the ground because that's who I am. I don't know Johnny. I don't know Johnny anything. Anyways, 20 equals negative 16t squared plus 26,400. This time I'm going to shift this over, make that positive. And 26,400 minus 20 is 26,380. Now the opposite of, first off, divide out the 16. We want to isolate t squared, right? That's what we want to do. So we're going to take our 26,380. We're going to divide by 16. And we're going to get 1648.75. So t squared is 1648.75. Now, unless you've been living under a rock, you know that the opposite of squaring is square rooting. And maybe you do live under a rock. Maybe you're like Patrick from SpongeBob. He lives under a big rock. And I get a square root of 40.60 seconds. So t is about 40.60 seconds. And he lives, by the way. I decided not to kill him. All right, now let's check the work. Back to y equals. I'm going to change that 1,000 into a 20. And I shouldn't have to play with my window. It ought to be adequate. If you played along, yours is too. So I hit graph. And I'm going to hit second trace 5 again. Which I should have done from the get-go. And I see my cursor, it's in the neighborhood. Enter, enter, enter. And sure enough, 40.6048. So, did it right. Good. Next up's a squirrel catapult. Alright, squirrel catapult, which is a real thing, launches a squirrel up at 64 feet per second from initial height of 4 foot. Write a quadratic model. So in America, all of our models start with negative 16t squared. Then we add in the initial velocity, which is 64 feet per second, so times time. And then we add in the initial height, which is 4. That's just how we do these things. There's your model. At what time will the squirrel be at its maximum height? That happens at the vertex, which we call the letter h. Remember that? The vertex, the x-coordinate is h. All right. That's at opposite b over twice a. We can do this one by hand. That's a negative 64 over twice a negative 16. That's going to be a negative over negative, so it's a positive 64 over 32, which is 2 seconds, because this was not x, this was time. So in 2 seconds, it's at its maximum height. To find the maximum height, all we do is we plug in a 2. So the height at 2 seconds is, let me write that where you can read it, negative 16 times a 2 that gets squared, plus 64 times a 2 plus 4. I feel like I can do this in my head. That's going to be 4 times a negative 16 is negative 64. That's 128. 128 minus 64 is 64. Add 4, 68 feet. Pretty good chance this squirrel's going to live. When will the squirrel land on the ground? The squirrel lands on the ground when the height is 0. Hold on, I'm recording. Just give me a minute. I'm not going to be able to finish this recording now. Alright, sorry about that. This one's probably not going to factor much, but that's what the quadratic formula is for. Now, one thing I can do is I can make the quadratic formula easier. I can pull a negative 4 from everything. That's going to make this 4t squared plus 16t plus 1. And yeah, I can guarantee you this thing doesn't factor. But I can pick out a, b, and c, and then I can do the quadratic formula. So it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, when I did this, this was a, this was b, and this was c. So 16 squared is 256. 4 times 4 times 1 is 16. I'm going to have the root of 240 inside that radical. And I'm not going to be too worried about simplification, all right? Because this is a real world problem. I'm not going to sweat it, okay? And obviously we need to check me. I'm pretty tired. So let's check my math on the whole 16 squared minus 4ac part. Hopefully I'm right. Nope, I put a 4 in the wrong spot, but that's no big deal. So yeah, it's root of 240. Now, the square root of 240, it's a little over 15. It's roughly 15.49. Okay, so what I have here is I have a negative 16 plus or minus 15.49. And something seems off about this. It is. Those were supposed to be negatives, weren't they? Bummer. Bad Milbrath. Let's go check this again. That's not going to change that piece, but it is going to change that. I just can't seem to get anything right today. 272. If I hadn't made a mistake, I'd have been good to go. The reason I knew something was wrong is because I was about to have negative time either way I looked at this problem. All right, square root of 272 will be a little over 16. 16.49. And both pieces are sitting over 8. This thing's not in the air that long. So if we take the negative 16 and we add 16.49, all we're going to have left is the 0.49. We divide that by 8, and this just, of course, he doesn't go very far up in the air. 68 feet. That does not seem right. Because that's positive. Because it's a negative. Okay, trying again. 16 plus 16.49 is going to be 32.49, and that's the guy that I'm going to divide by 8. And that's the one that works. The other one doesn't make any sense because it'd be negative time. And we get about 4.06 seconds. I'm using X here, but it's actually time. Time is about 4.06 seconds. I knew he was in the air not long enough. All right, now let's check this with the TI-84. So we can check it with the TI-84 simply by graphing. So good old y equals is where it's at, right? The equation for the squirrel catapult was negative 16x to the second plus 64x plus 4. And I wanted to know when the squirrel hit the ground, and the ground is 0 feet off the ground. And zoom 6 should do the job. Now if you want to see the actual thing, Windows settings, an X max of about 50 is good, X max at 10 is good. We know he only goes 68 feet in the air, so let's change Y max to 70. And we're going to check everything. We're going to check part 2 and part 3. We're going to check part 2 using what's called the maximum function on a TI-84. So here's the squirrel's trajectory to some degree. What I'm doing with y'all isn't 100% right. There's more to these equations. But if I want to know the squirrel's maximum height, I'm going to choose function 4. And the maximum works by getting your cursor to the left. See where it says left boundary? And pressing enter. And then getting your cursor to the right of the maximum and pressing enter for a guess. And we came up with 2 seconds, and the calculator has a 2, it just has a rounding error. It's not perfect, just like anything else made by a person. The other thing I want to know was when it hits the ground. And remember, I put a 0 into Y2, so I'm going to get close to my red line down here, and then I'm going to press enter 3 times. Enter, 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 and there she is, 4.06 seconds. Now hopefully I have enough time to do another one here. Yeah, not bad. Oh God, that was only page 1. Ugh, this is taking forever. A picture has a height that is 4/3 its width. It is to be enlarged and have an area of 192 square inches. What will be the dimensions of the enlargement? All right, so I have a height that is 4/3 of its width. Which actually means it's taller than it's wide. So we'll call this its width. And that would make this 4/3 the width. Now I've just drawn a rectangle is all I've done. The area of a rectangle in terms of its width would be W times 4/3 W, at least of this rectangle. And W times 4/3 of W is simply 4/3 W squared. Now, I said this thing is going to be enlarged such that its new area is 192 square inches. So 192 equals 4/3 W squared. And we're not going to check this one in a calculator. It's just taking too much time. We're going to triple both sides. The opposite of division is multiplication, so we're going to multiply both sides by 3. 3 times 192 should be 576. Should be. I don't feel like checking it in the calculator. We're going to divide out the 4. How many times does that enter that one? 144 is W squared. And then the opposite of squaring would be square rooting. So it would be plus or minus 12, but because this is a real world problem, it's going to be 12. So this becomes 12, and this becomes 4/3 of 12. 4 times 12 is 48, divided by 3 is 16. So what I just learned is I learned that the width is 12, and the height is 16. And it can be checked in a calculator. What you do is you just put this in Y1 and you put that in Y2, and you play with your window settings. All right, moving forward, we have the product of two consecutive negative integers is 1122. So you probably don't know what a consecutive integer is. Consecutive integers differ by 1. That's all they do. They are the next thing. When we say consecutive, we mean in order. So like 1, 2, 3 are consecutive. The big thing is they differ by 1. Now to solve this problem, we're going to call the first integer x. The second, since they differ by 1, is simply x plus 1. Now, I know that their product is 1122. So I know product means multiplication, and I hope you do too, but x times x plus 1 should equal 1122. You know, this is straight up, use the distributive property. X times x is x squared plus x, shift left, minus 1122 is 0. And I am quite certain that thing factors. I just don't want to think about it right now. I kind of do, but I don't, because I'm mentally exhausted. So I'm just going to do some quadratic formula on it, and I hope you're okay with that. It's not going to be pretty. I could complete the square. No? All right, so bx equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so let's see what's in there. And it's going to work out nice. This problem is supposed to work out nice. Now, pay attention that they are consecutive negatives. So it's not the positive aspect I'm going to keep. It's the negative aspect that I'm going to be keeping. All right, so what's in that radical? There is a 1 that has been squared. And I told you all to use parentheses, and I'm not using them. There's a 1 that's squared. We're going to take away 4 times a, which is 1, times c, which is negative 1122. So inside that radical is 4489, which is a perfect square. I know you probably don't believe me, but it is. $66.7. What are the odds of that? Ha! So x is going to be negative 1 plus or minus 67, sitting pretty over at 2. Now, it said negative integers, so the only one I care about is the one that generates a negative. So that's going to be negative 68 over 2, which is negative 34. So the first one is negative 34, and the second one is negative 33. Now, is this technique right? Well, I mean, let's see. I'm telling you it's negative 34 and negative 33. Hopefully it multiplies together to be 1122, and it did. Who'd have thunk? Who'd have thunk? Bummer, I did not get to finish all these. I got 6 minutes, but I got a good start on it, so I'll stop. All right, so part 2. A garden measuring 12 by 16 meters is to have a pedestrian pathway installed all around it, increasing the total area to 285 square meters. So what they mean is a sidewalk, right, or just a place to walk. So you've got a garden. Be cool if that was in the right spot there. And she is 12 by 16. There we go. Now, what they're going to do is they're going to install a walkway around it, and we're going to make the assumption that it's pretty much a regular figure. In that, what we're doing is we're increasing by x. So the width of the walkway is just x. Now, think about what's happening to this 12 down here. I was 12, right? And now I am 12 plus 2 x's. I was 16, but now I'm 16 plus an x here and an x there, plus 2x. Now, this increases the total area to 285 square meters. So this is a rectangle. We should know that the area of a rectangle is length times width. It always will be. So I've got a length of, I guess I'll use the 16 plus 2x. Area as a function of x is 16 plus twice x times 12 plus 2x. And there's my area function. Now, I happen to know that the area is 285 square meters. And now I have a function. If I felt like it, this would be a great problem for a graphing calculator, and I might. I'm low on time here, that's all. But, you know, my job here is teach algebra. I hate it for you. Let's box this out. We got 16 plus 2x, and then we got 12 plus 2x. 12 times 16 is 160 plus 32, 192. 12 times 2x is 24x. 2x times 16 is 32x. 2x times 2x is 4x to the second. So I did all that fun math on the right-hand side. Okay, I got a 4x squared. I got 32 and 24, which makes 56x. And then I got 192 as my constant. And that is equal to 285. So next move is take 285 away from 192, which I feel like that's going to be negative 97. I'm 8 away. I'm probably off pretty bad today. Let's make sure I'm doing things right. You ever just have a bad day? I'm having one of those. And it's not an emotional thing. I'm just wore out, man. So anyways, I need 192 minus 285. I feel kind of shameful having to do this. Be quite honest with you. It was negative 93. So whoever designed this problem did not want it to come out pretty, did they? They sure did not. Let's make sure I did the box method right. 16 times 12 would be 160. 32, nothing wrong there. 32x, 20. Well, I sure don't see anything wrong with it. So yeah, it's just a problem that's not going to come out pretty. That's all there is to it. So you get to do the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Or maybe it does work out and I'm just too slow this morning to realize it. All over 2a. So let's see what's in that radical. I thought this one came out with a halfway decent answer. That's why I was a little curious if I had made a mistake or not. So inside the radical is 4624. It's all over 8. Let's see what the square root of that number is. Oh, it's 68. So yeah, it does work out. It turns out that ugly looking thing would have factored. 3 and 31. Yes, it would have. Would have been 3 and 31. Don't you hate it when you see something when it's too late? But it did factor. Alright, so anyways. Well, maybe it wasn't 3 and 31, but it would have factored. So we got x equals negative 56 plus or minus 68, both pieces sitting over an 8. Now, only one of those things makes sense. If you do the negative 56 minus 68 over an 8, oh, what do you have there? You have negative 122 over 8, which is negative 16. No, it's not negative 16, but it's negative 61 over 4. But it doesn't make sense because this is talking about a dimension, so this guy is extraneous. The only one I'm actually interested in is the plus. If I do negative 56 plus 8, I feel like I get 12. I divide that by 8 and I get, a real world measurement of 1.5. So it turns out the width of the pathway is 1.5 meters. And it is in meters, by the way. Not necessarily too hard of a problem. But, I had to use a calculator on it because I'm that tired. And moving on with our lives here. You have a 500-foot roll of fencing and a large field. Come on, I want you out of my way here. Uh-oh. Calculator does not want to move, does it? Come on. This is where my software usually crashes on me. Wonderful. All right, let's move this over here then, since the calculator does not want to get out of the way. And hope that I don't need it. Oh, there we finally. You decided you want to do something? Man, this thing is totally about to crash on me. Come on. Sorry, people. There we go. You have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground. What are the dimensions of the largest such yard? So this one has all 4 sides. And you've got your widths and you've got your lengths. And the perimeter would just be the default perimeter for a rectangle, which is 2 lengths plus 2 widths. And it's 500 foot. So 500 is 2 lengths plus 2 widths. A lot of people teach these only in terms of x, but I like to stick with geometry and keep my lengths and widths in here. Now, the area of a rectangle is length times width. We need to solve this equation for either length or width, and I'm just going to choose length on this one. So I know that 2 lengths is 500 minus 2 widths, and then I'm going to divide out the 2, and the length is 250 minus a width. And I'm going to plug that in right there. And this is going to give me an equation with a singular variable. And that's the only way you can actually solve an equation, if you just have one. So I use substitution, and this isn't the first time you guys have seen this one done. But the area in terms of the width is going to be 250w minus w squared, which in standard form is negative w squared plus 250w. Now I want to think that on the last quiz I gave you, about half the student body got this right. I want to maximize the area. It says what is the largest area. that is going to happen at the same place it always does, which is the vertex, opposite b over 2a. B is going to be 250. Opposite that's a negative 250. Remember, this is b, this is a, and it's negative 1, over twice a negative 1. Now, a negative 250 over 2 is 125. So let's throw those dimensions on our rectangle here. We found the width, she was 125. We found the width, she's 125. You put those together, you get 250 units, right? The lengths are the same. They are also 125. What happens is, if you have a four-sided figure, you maximize area by making a square. And we even talk about area in terms of square units. The largest such area here would be to take your 125 and multiply it by 125. Let's see if my calculator works right this time, or if it's going to be completely froze. So anyways, 125 times 125, or just 125 squared, is going to be 15,625 square feet. Ta-da! Not magic, it's just math. All right, let's move on to the next one here. You have a 1,200, I'll pause. All right, so maybe I can finish this now. You have 1,200-foot roll of fencing and a large field. You want to make 2 paddocks by splitting a rectangular enclosure in half, or the dimensions of the largest such enclosure. So I always say this, or at least I try to, but a picture is always worth 1,000 words. You're going to split this thing in half, all right? Now, when you start talking about dimensions here, you got a length here, you got a length here. But because of how you're splitting your fences, you actually have 3 widths. So normally your perimeter of a rectangle is 2 lengths plus 3 widths, but because of the way this thing is constructed, your perimeter is 2 lengths, and I may have said that wrong, plus 3 widths. I hope you get that. Now, I do know that the perimeter is 1,200 because I have 1,200 foot of fencing available. All right, moving forward. I know that the area of a rectangle is length times width. And we're going to do this one the same way we've done a lot of these problems, okay? It's not too hard. This time, for no good reason, I'm going to solve for the width. So 1,200 minus 2 lengths is 3 widths. And you have to solve for the width, so you have to divide the 3 out. And that'll make that 400 minus 2/3 the length is the width. And now we get to use substitution property just like I did on the previous problem, all right? So this time, everywhere I see a W, that's what I become. On the previous one, I think I solved for L. It doesn't really matter which one you solve for, but you got to solve for one of them. Anyways, this one's going to be the area in terms of the length is going to be length times 400 minus 2/3 of L. And then, of course, you get to use that property that starts with a D. I think we call her the distributive property. And I'm going to put that negative 2/3 L squared out front plus 400 L. And the reason I go after standard form is because I know that area is maximized at the vertex, right? Right? So, the L coordinate that maximizes volume is going to be opposite b over 2a, which would be a negative 400 divided by a negative 2/3. That's going to be positive, and it's going to be 600. How do I know that? Because it's going to be 600. But anyways, let's just make sure that Milbrath is right. And let's play with the calculator over here. Hey, there she goes. Well, we have a negative 400. We divide it by, a lot of kids are always amazed that I can do fractions. That's actually not anything special. It's really not. 600. So, my length is 600. I think that was that in feet, meters? That's 600 feet. Now, it may not be apparent to you, but when you put, that seems too much, doesn't it? Where have I made a mistake? there is a mistake. Let me pause this real quick. There has to be a mistake somewhere. The mistake is, you know, I'm sitting here talking about being able to do fractions, but I can't plug into equations properly. It's over twice a negative 2/3. Anyways, that's going to change that to 300. Now, the reason I knew there was a mistake is because if these two lengths were both 600, I wouldn't have anything for the width, now would I? All right, so this is 300 and this is 300. That means you've taken up 600 total feet out of 1200. It's going to give you 600 left that you have to split into three parts because there's three different W's here. So each W is going to be 200 foot. I'm doing it as easy as I can. I'm doing it non-algebraically to some degree. Now, that's all they asked for. They asked for the dimensions. The length is 300, the width is 200. Not too bad of a problem. Erase, pause, BRB. All right, where are we at now? Ooh, the last page. About time. The farmer wishes to enclose part of a field. He will only need to fence three sides. We had one of these on your last quiz. As the third side borders a river. It's kind of like the last one. In this example, though, your rectangle has two widths and a length. And we have 5,280 feet. He has a mile of fencing available. And that would be equal to the sum of both widths plus the length. Now on this one, I would go ahead and solve that for 2W. But what do I know? Now again, formula for area of a rectangle is length times width. And we're just going to plug in. I've solved for L, so it's going to be L times 5280 minus 2W. So the area as a function of length is going to be, that should be a W. I replaced L, right? Yeah. Put that. Forgive me, I am really off today. Negative 2W squared, distributive property, kids, plus 5280W, if I can write. Now, kind of the same idea as last time, our vertex, our maximum happens at the vertex. And of course we find the vertex using opposite B over 2A. So that needs to be a W. The maximum width is at opposite B over 2A, which is at negative 5280. Sitting pretty over twice A, and A is negative 2. This should work out. We're taking a negative 5280 and we're dividing her by a negative 4, which is a big number. What is it? Negative 1320 maybe? I don't want to get it wrong. Maybe the calculator will work, maybe the calculator will not. There she goes. Milbrath tired. Grading y'all's papers. It's wearing me out today. I just graded about half of the basics 6 quizzes. So the width is 1320. Now let's just go back over to our rectangle. If there's 1320 there, there's 1320 there. If you take two 1320s and put them together, and I know this is what gets a lot of y'all, is your just ability to do the basic math. And that's something that y'all need to work on to get 2,640, which oddly enough happens to be half of 5,280. But that means that the length is also 2,640. Because it took two widths to make a length. That's kind of how these problems work. All right, so the maximum area here, it's going to be fairly large. You got 1,320 square foot. And you can turn around and multiply it by 2,640 square foot. And it's not going to be quite a square mile, but it's going to be a good bit. It won't even be a quarter of it. It's not going to be a square mile. If you're thinking like, oh, I took a mile of fencing, I have a square mile. It's not. It's nowhere near a square mile. You get this gigantic number, which seems like a lot. It does seem like a lot. 3,484,800. And that might seem like a lot. It is actually a pretty big plot of ground. An acre has 43,560 square foot. So it's an 80. It's what we call a half a quarter. So it's 80 acres on the money. It's not bad. 80 acres. Bigger than I thought it would be, to be quite honest with you, and that made up a problem. All right, so your factory produces lemon-scented widgets. You know that each unit is cheaper the more you produce, but you also know the cost will eventually go up if you make too many widgets due to storage requirements. The guy in accounting says that your cost, and there are people who do this kind of stuff, says your cost for producing X thousands of units a day can be approximated by the formula cost is 0.04 x to the second. The way that wrote that didn't turn out too good. Minus 8.540x plus 25,302. Find the daily production level that will minimize your costs. So the idea here is that the max or the min happen, and it's not a hard thing to do, at the vertex, which is opposite b over twice a. So this is like a really simple problem, super duper simple problem. So b is that funky decimal 8.504. It's negative b, so we're going to have to make that number a positive. And that's sitting over twice a, which is 2.04. And then we're just going to push some buttons and we're going to be done with it. It's not a hard problem. No, I lost my calculator. I don't think I can get it back. Oh, I did. Sweet. So we got 8.504. Play along. I'm old school, so I do things left. I write things horizontally. So I got to use parentheses. 2 times 0.04. See how it's wrapped. Milbrath-Math's ninth commandment of math says that if you have 2 or more things, you wrap instead of parentheses. And you get 106.3. Now, I want you to know that that's thousands. All right? Thousands. So that would be 106,300. You shift the decimal to the left, or sorry, to the right, 4 places. That's how you multiply by 1,000. And we have one more to go. And it's a problem that every class but 5th period asked me about. Shame on you, 5th period. No, 5th period did ask. Let me take that back. It wasn't 5th period. It was 6th, maybe? Yeah, 5th period didn't ask me that day about the Mars question. But actually, every class asked about this one. A rectangle has a length of 5x minus 15 and a width of 20 minus 4x. Find the real-world domain for this rectangle. So if you're listening to this muted, you probably have no idea why I'm writing this. But length must be greater than 0. Length has to be greater than 0. And the same thing's true about width. 20 minus 4x has to be greater than 0. So let's add 15 here. 5x is greater than 15, and this tells me that x is greater than 3. I'm going to shift my 4x over here. 20 is greater than 4x. Divide out by 4. It tells me that x has to be less than 5. All right. And we're going to take a look at this one on the calculator. And this is not a bad spot to just go ahead and take a look on the calculator and just talk about how to do this in a calculator. It's really not. So I'm going to y equals, and I know, and you know, that the formula for the area of a rectangle is simply length times width, right? So we have a 5x minus a 15. I hope you know that. And we also have a 20 minus a 4x. I need to be rolling here. Anyways, I'm going to zoom 6 it. And maybe you comprehend graphs, maybe you don't. I know that's an issue. It's always an issue. I wish it wasn't. But this stuff doesn't make sense if it's below the x-axis, because that's where area is negative. So the only thing that makes sense is where area is positive, and that's between 3 and 5. You see what I wrote up there? So literally, I'm saying I'm bigger than 3, but less than 5. All right, find the area of the rectangle in terms of x. So we're going to do on paper what I kind of did in the calculator there. It's 5x minus 15 times 20 minus 4x. Let's just go ahead and box this thing out. A lot of y'all are using the box method. I'm cool with that. It does not reinforce factoring. That's the only issue with it. But I'm giving it a shot this year. 5 times 20 is 100. Don't forget the x. 20 times negative 15 is negative 300. Negative 4 times 5, negative 20x to the second. Negative 4 times negative 15 is positive 60. Don't forget the x. And that's a square. So this becomes negative 20x to the second. Looks like plus 160x. And then I think minus 300. And that's the area as a function of x. What value of x maximizes the area? What is the maximum area? So again, that happens at opposite b over 2a. You catching on to that? I hope so. That's negative 160 over twice a negative 20. That's negative 160 over negative 40, which is 4. What is the maximum area? Well, you can find the maximum area by plugging it in. And, you know, let's just draw the darn thing. And let's just plug in numbers. 5 times 4 minus 15 is 5, right? 5 times 4 is 20, minus 15 is 5. 20 minus 4 times 4, I'm looking up here. 4 times 4 is 16. 20 minus 16 is 4. So this tells me that the area is 5 times 4, which is 20. Now, how do I use a TI-84 to assist with that? Well, you'll notice earlier that I had graphed. Lost it. Let's get that back. Let's look up. Go to Window, set your Y max to, I don't know, 30. It'll do the job. And hit the graph key. Now, there is a maximum function in the calculator to help you find vertexes. There's two of them. There's a maximum and a minimum. Second trace 4 finds a maximum. And it works by having left boundaries and right boundaries. So I'm going to take my cursor and I'm going to get it close to the maximum of the graph. And I'm having to press the arrow while to find her. I'm going to press enter. Now it wants a right boundary. So I'm going to go to the right of the vertex and I'm going to press enter. Then I'm going to press enter a third time for the guess. And the calculator does have an issue with rounding these things, but that's pretty close to 4, isn't it? And if you look at the Y value, the output, that's your area. All right, that's it. I'm done. Hope you enjoyed. Hope you liked the new board. It took me 3 times as long to do this video.